Alright, so I know we've already graphed cotangent, but now let's graph cotangent a little bit faster now that we know the phi values. So now we're going to practice, right? So we've got to know, right, at 0, the cotangent of 0 is going to be undefined. Right, at pi over 4, we know that we're going to get a positive value of 1. At pi over 2, we know I'm going to get 0. 3 pi over 4, negative 1. And then at pi, I'm going to get undefined. Okay, so let's go ahead and graph this out, right? With cotangent, we know we're going to have undefined at 0. And we know we're going to have undefined at pi. And all we need to do is just plot our points. We know we have the points at pi over 4, we get the value of 1. We know at pi over 2 we get 0. And we know at 3 pi over 4 we get negative 1. And we know that if we go to the left, it's going to kind of curve up. And as I go to the right, it's going to kind of curve down. It looks something like that. Okay, oh well, not perfect, but it's close enough. Let's go ahead and look at the features of cotangent now. Okay, so I wanted to graph cotangent one more time. You know, practice makes perfect. The more you practice this, the more, you know, the easier it is going to be to remember. So at 0, we know we have undefined. At pi, we know we have undefined. And then we know our values of cotangent. At pi over 4, we know is 1. At pi over 2, we know is 0. And at 3 pi over 4, we know is negative 1. And we know it's going to kind of curve as we, whoops. We know this is going to kind of curve as I go to the right. I'm sorry, to the left, and curve down as I go to the right. Let me kind of zoom out. All right, so there's our cotangent graph. Let's go ahead and go through this. Since we've already done tangent, this is going to be pretty much the same idea, just some values are going to be slightly different. For instance, the domain, right, our x values for the domain are different. We know that all of the x values are now in between 0 and pi, right? We can see that all of the parts of the graph are in between 0 and in between pi. So that's our domain. We can write this in interval notation as 0, comma, pi. We use parentheses because it could never touch 0 and pi. Right, our range, just like tangent, it's all real numbers. It goes up and down forever. Our amplitude, just like tangent, is the distance from the x-axis to the point at pi over 4. Right, so in this case it's 1. And then exactly that distance, even though it's going down, it's still a distance of 1. So our amplitude is going to be equal to 1. All right, what's our period? Our period is just going to be, well, how long does it take for the values to start repeating? Well, it's going to take pi. This is the period. The period goes from here, all right, this is one period. It goes from here to here. All right, that's one cycle. If I were to continue this, you would see another, whoops, you would see another cotangent up here if we were to continue drawing this. All right, I don't have space for it, but another period of cotangent would be on that side. So this has a total period of pi before it starts to repeat. X and y intercepts for tangent and cotangent are really nice because they're both at 0. And interval of increasing. Okay, just the way tangent is always increasing, cotangent is always going to be decreasing. So the interval of increase is none, right? We don't have any interval of increase. What's the interval of decrease? Well, it is the entire domain from 0 to pi. It's decreasing on that entire domain. All right, so there we go. Let's go ahead and look at our next trig equation. All right, guys, we're going to go ahead and graph the cosecant of theta. So one thing we need to know about the cosecant of theta is that this guy is going to be a reciprocal of the y value, right? Cosecant is the reciprocal of sine. Sine is equal to y, so cosecant is going to be equal to 1 over the y value. All right, so don't confuse that with the y value over here. This y value, we can think about this as more like f of x. right? So try not to confuse yourself. That just means that's the output. With cosecant, this y value really means it means that it's the y value of the unit circle. So we're going to go ahead and plot. Those y values onto my graph. Let's first go ahead and start off with our angle at 0, right? We're going to start with 0. So here at 0, I'm going to erase all the other ones. So here at 0, I'm going to go ahead and take the reciprocal of 0. So this is really going to be equal. So at 0, when theta equals 0, when theta equals 0, we're going to end up with 1 over 0, which is, we know is going to be undefined. So we know that whenever there's something undefined, we know we're going to have an asymptote. So at 0, we know that we're going to have an asymptote going straight through. Let me do it in a different color, actually. That way we can see it a little bit better with the black y-axis going through it. Okay, there we go, a lot better. So there's our undefined value, or undefined asymptote. Now we're going to go to the next. Now we're going to go to our next angle, right? So our next angle, right? It's going to be this guy. It's going to be my 1/2. So when theta is equal to pi over 6, right, we get 1 over 1/2. So all we got to do is flip it. Just flip the 1/2, and we get 2. So at pi over 6, so pi over 6 is going to be right before pi over 4. This is pi over 4. We know pi over 6 is about 1/3 of the way. That's pi over 6. And then we know that pi over 3 is about 2/3 of the way to pi. Okay, so at pi over 6, we've got 2. So there, oh, we're going to do this in red. So we're going to get 2. Perfect. Let's go to the next angle now. So my next angle I'm going to have is radical 2 over 2. So when I'm at pi over 4, we do 1 over radical 2 over 2. Just flip it, right? 2 over radical 2. If I plug that into my calculator, that's going to give me 1.41. Right? I'm going to get 1.41. So at pi over 4, we've got 1, and then 0.41 is about halfway. Maybe a little bit less than halfway. 0.41, somewhere around there. Looking at pi over 3 is my next one. So we're going to flip the y value. We're going to flip the next y value, which is going to be radical 3 over 2. So I'm just going to flip that guy. So we get 2 over radical 3, which is going to be equal to 1.15. Right? I'm just going to round it there, 1.15. So at pi over 3, we've got 1 and a little bit more, 1.15. So you can tell it's a little bit above just 1. All right, I think that's pretty good. Then we go to pi over 2. So at pi over 2, what is the reciprocal of our y value? So here's pi over 2. Right, here's my pi over 2. There's my y value. I'm going to flip it. Well, if you flip 1, you're just going to get 1 again, right? So you're just going to get 1. So let's go ahead and plot 1. So at pi over 2, we've got 1. All right, let's keep going. I'm going to go a little bit faster to this next part. We already have the values of everything flipped, so let's go to the next value. The next guy, so this guy right here, radical 3 over 2 flipped. We know radical 3 over 2 flipped is right here, 1.15. All right, it's like right about there. Next guy we have is going to be radical 2 over 2. We have that one right here, so it's 1.41. There we go, a little bit less than halfway. Then for the next one, we've got 1/2. The reciprocal of 1/2 is 2. So at 5 pi over 6, we've got the reciprocal of 1/2 is 2. There we go. And then let's see what happens at pi. And then at pi, If you flip 0, you're going to get undefined. There we go. And then we get undefined. Okay. Let's look at our shape now. Let's go ahead and let's analyze our shape a little bit, and let's see what kind of shape is this going to make. So if you notice, as we go to the right, or as we go to the left, right, we know that a rule of the asymptote is the graph is going to get closer and closer to the asymptote, but it's never going to touch it. So that's going to kind of end up looking kind of like a parabola, and to the right as well, right? So I go to the right, it gets closer to the asymptote, but it's never going to touch it. So we end up with this parabola-looking shape. Let's see if the same thing happens on the other side. All right, again, I'm going to go a little bit faster this time. So I'm going to flip -1/2, negative radical 2, and the negative radical 3 over 2. All right, so if I flip -1/2, I'm going to get -2. So right about there. If I flip negative radical 2 over 2, all right, I'm going to get -1.4. So -1.4. If I flip negative radical 3 over 2, that's going to give me 1.15. So 1.15. And then at 3 pi over 2, if I flip, sorry if I highlight that one, if I flip -1, I'm just going to get -1. So notice we're getting that exact same shape again. So then we keep going. Let me look at the next quadrant. All right, if I flip negative radical 3 over 2, I get my 1.15. Then I'm going to get my 1.41. Then I'm going to get 2. And then at 2 pi, if I flip 0, right, if I flip 0, I'm going to get undefined again. So at 2 pi, we know we're going to get that undefined asymptote there. And let's go ahead and draw our shape in. We're going to get that parabola look all over again. All right, and there we go. So there's our cosecant of theta. So it kind of looks like these little parabola points. So the way this is typically taught is, since cosecant is really the reciprocal of sine, right? Sine of theta, right, is the reciprocal of cosecant of theta. So typically what we do is we graph sine. If you were to graph sine here, right, sine starts at 0, then goes to 1, then goes to 0, then goes to -1, and then goes back to 1. So this is sine. Right there. So the strategy that we use when it comes to sine, or sorry, when it comes to cosecant, is if you notice sine, notice what happens every time the graph hits the x-axis. Whenever sine is equal to 0, notice what you get. You get asymptotes. And then also notice what happens at the highest peaks. Right? So notice what happens at the highest peaks of sine. Those peaks become your parabolas. Okay, so when we are going to graph this, what we're going to do is we're just going to graph sine. All right, I'm going to graph sine out. And then wherever the graph hits the x-axis, I'm going to draw my my asymptotes. Right? I'm going to draw my wherever it's, whoops, I do not want to do that. Wherever it hits 0, there's an asymptote there. Right? Wherever it hits 0, there's an asymptote. Wherever it hits 0, there's an asymptote. And then wherever you see peaks on your graph, right? Wherever I see a peak, oh, there's a peak, parabola. There's a peak, parabola. Okay, so you don't really need to know the table for this, but just because we did it for the other ones, we know this is undefined. We know at pi over 2 is 1. At pi it's undefined. Then we get -1, and then we get undefined. Okay, so you can memorize that table if you would like as well. Let's go ahead and practice this a little bit more, and then we'll move on to the next one.